Hey guys, welcome to the last lesson in Chapter 7, Scale Drawings and Models. In this lesson, we're gonna work with some scale models, and we're going to use scale factors. Use scale factors to solve some problems. We've got some new vocabulary here. Scale model or drawing. This is an object or a drawing with all dimensions proportional to some real life object that it represents. So there's that word proportional again, basically just meaning that we have similar figures, right? And the most common example of a scale drawing that you might see would be probably be a map, right? And nowadays we have Google Earth, and you can think of Google Earth just as a virtual map or a virtual scale drawing. Now on a map, or on a model, you're going to have a scale, and that scale is the ratio of a dimension on the model to its corresponding dimension on the actual object it represents. So on a map, you might see this as maybe 1 inch equals 50 miles, for instance. Okay, and you'll notice that with scale, we always have units involved. Okay, and generally they're not the same units. Notice that I've got 1 inch equals 50 miles. It would not be practical to have a scale on a map that says 1 mile equals 5,000 miles, for instance, because it's just not practical to measure a mile on a piece of paper. Likewise, nor is it practical to picture what 500 million inches would represent on the face of the earth. So on a scale, you're generally going to see it like this. 1 inch on your paper and your model represents some other unit or some other number of units in the real world. Now that's as opposed to a scale factor. Now, a scale factor is basically sometimes you just want to know how many times bigger is this thing than its model. How many times bigger is the real thing than the model? So it's a unitless ratio written in simplest form that represents how many times larger an object is than its model. So for instance, I could turn this into a number. I could say, well, how many inches are in 50 miles? And then I could put that into a ratio. I'd have so many inches over so many inches, and the inches would cancel themselves out, and you'd have left nothing but just a factor. Okay, so we're going to work with both of those and see how we can use them to solve problems. Okay, the distance between New Ipswich and Concord on a map is 9 inches. If the scale of the map is 1 inch to 4 miles, you might see that written as 1 inch equals 4 miles. What is the actual distance from New Ipswich to Concord? So you could set this up as a proportion. You could say 1 inch over 4 miles equals how many inches on the map? 9 inches on the map. 9 inches over X miles. Okay. And we could cross multiply here, and we get 1 times X is X equals 9 times 4 is 36. Okay, so X equals 36. So the actual distance would be 36 miles. Now you'll notice the convenience of having a scale written as a single unit, having it reduced to a unit on the paper, because that allows you to simply multiply the distance you measure times that scale, and you get 9 times 4 is 36. If I've got 9 inches on the map, and every inch represents 4 miles, then 9 times 4 gives me a total of 36 miles. All right, here's another one. The distance between Boston, Massachusetts and Hartford, Connecticut on a map is 3 inches. If the scale of the map is 1 inch to 30 miles, what is the actual distance from Boston to Hartford? Well, this scale is written very conveniently in terms of 1 inch. So if 1 inch equals 30 miles, and I've got 3 inches on the map, then I've got 3 times 30 equals 90 miles. Now, it is good to picture just how you write that as a proportion, because if you didn't have such a convenient scale, what if they said 5 inches equals 200 miles? Then you might want to set it up like this. 1 inch over 30 miles equals 3 inches over x miles. Okay, and again, you'll see your cross products. 1x equals 3 times 30 equals 90 miles. Good. Okay, a model of a yacht is 4 inches long. The actual length of the yacht is 14 yards. What is the scale of the model? Well, we could write this as 4 inches to 14 yards. Okay, but how would we make it really convenient like those other scales we had in those last two problems, where we had it in terms of 1 inch? That would be a lot easier to work with. Well, basically what we're going to want to do is just reduce this fraction so that the numerator is 1, a unit. And you can see that I would have to divide the numerator by 4 in order to get that down to 1. So I'll have to divide the denominator by 4 as well. And so I'm going to get 1 inch over, what is 14 divided by 4? What do we get? We're going to get 3.5 yards. Okay, and you might see this written as 1 inch to 3.5 yards. Just another way to write a ratio, right? Now, what is the scale factor? Okay, remember, scale and scale factor are a little different. Scale factor is a unitless ratio. So how many, if it's 1 inch to 3.5 yards, how many inches are in 3.5 yards? Well, I could say 3.5 yards. I got 3.5 yards. Do you guys remember dimensional analysis from Algebra 1? And I could say, well, I'm going to multiply that by 3 feet in a yard, right? I could say 3 feet per yard, right? And I can multiply that by, remember, I'm going after inches. I could say 12 inches per foot, okay? And let's see what we get. Because what's going to happen here is, notice yards are on the top. They cancel the yards on the bottom. Feet are on the top here. They cancel on the bottom. So I get 3.5 times 3 times 12. And it turns out there's 126 inches in 3.5 yards. Okay. So now I'm going to rewrite my scale as 1 inch per 126 inches. And you'll see now the inches, now the dimensional units cancel each other out. So I've got a scale of 1 to 126. In other words, the real yacht is 126 times larger than the model. All right, let's try another example like that. And this is a point where you might want to pause the video and try this one on your own before you watch me do it. A model of a castle is 9 inches tall. The actual height of the castle is 32 yards. What is the scale of the model? Okay, so we could write that as 9 inches on the model represents 32 yards in real life, right? So could we reduce this to a nice convenient unit scale? In other words, I'd like to say if 9 inches represents 32 yards, then 1 inch represents how many yards? Well, you can see I'll have to divide that numerator by 9 in order to get that down to 1. So I'll have to divide the denominator by 9 as well. Notice I'm really just dividing by 1, which doesn't change the value of it, right? 9 over 9 is just 1. So 9 divided by 9 gives me 1 inch over 32 divided by 9 gives me 3 5/9, right? And I don't know if you want that as a decimal or not. I actually like 3 5/9 yards. I'm totally okay with that. If you like a decimal, 32 divided by 9 gives you 3.556. So you might say 1 inch equals 3.556 yards. Okay. what is the scale factor? Now remember, scale factor just wants to know how many times bigger is the castle than the model. So, well, we could go through that dimensional analysis again. We could say, all right, 3.556 yards. Okay, and now you might want to take a little shortcut here. I know some of you are saying, hold on, I know there's 36 inches in a yard. So maybe you want to say, multiply that by 36 inches. 36 inches per yard, right? And when we're done, the yards will cancel and I'll have inches so that I can compare inches to inches. All right, what's 3.556 times 36? And that gives me conveniently exactly 128 inches. Okay, so it turns out that 1 inch, I have 1 inch on my model per 128 inches on the real castle. And so the inches are going to cancel and I'll be left with a nice scale factor, 1 to 128, which you'd probably write as 1 to 128. Or you might say the castle is 128 times larger than the model. Okay, what is Dave up to this time? Dave is making a scale model of his barn on a piece of paper that measures 11 inches by 17 inches. His barn is 20 feet by 32 feet. What would be an appropriate scale for the drawing? Okay, so an appropriate scale. Well, his barn is 20 feet by 32 feet. I'll just make a quick sketch here. Here's our barn. What are the dimensions? 20 feet by 32 feet. Good. And he's got a piece of paper that he wants to draw this on. And this paper is 11 inches by 17 inches. Okay. All right, so I'm going to check a couple of things here. I'd like this 32-foot dimension of the barn to fit onto the 17-inch dimension of the paper. So in other words, I could say 17 inches per 32 feet. Okay. And let's divide both top and bottom by 17 there, right? To get that down to a nice unit and see what we end up with. So I end up with 17 divided by 17 is, of course, 1. And 32 divided by 17 gives me 1.88. Okay, so what does that represent, or 1.882? That's inches per foot. Okay, but I got to check and just make sure that if I put that dimension on the paper this way, will the width also fit, or will that go off the paper? So I also want to check and see if this 20-foot width would fit onto the paper at that scale, because that would be 11 inches per 20 feet. All right, and oops, let's go ahead and get that down to a unit so we can compare it. And divide that by 11 over 11. Remember, I can divide or multiply anything by 1 and not change its value. So I get 1 inch per how many feet? 20 divided by 11 gives me 1.818. Now, the question said, what would be an appropriate scale for the drawing? If I used this scale, I would actually run out of room trying to draw this dimension on the paper. So I could use this scale, but is that a good scale, or could I choose something more convenient? If you really want to work with some easy numbers, you might want to take this guy and say, let's make him 1 inch equals 2 feet. And that'll make all of your work really, really easy. If we did use this scale, 1 inch to 2 feet, what would the dimensions of the barn be when we put it on the paper? Okay, if 1 inch equals 2 feet, I'm going to divide 20 feet by 2, right, to get 10 feet. So, 10 inches. 20 feet divided by 2 feet leaves me with 10 inches. Okay, and then what's this dimension going to be? 32 divided by 2 is going to give me 16 inches. Okay, and another thing to note is another reason why you want to maybe round up there is you don't want to be drawing like right on the edges of the paper. You want to leave yourself some margin. So here, 1 inch equals 2 feet would be an appropriate scale. And if he did that, then on his paper, the barn would be 10 inches wide by 16 inches long. Good. Okay, let's check out the next problem here. Oh, what's this? My goodness. Look at that. That might come in handy. Okay. All right. Dave is taking a class on architectural modeling. He's making a scale model of a house in a 16-inch by 28-inch display case. The house is 72 feet wide by 132 feet long. What would be the dimensions of the model using a scale of 1 inch equals 6 feet? Okay. So if 1 inch equals 6 feet, then this 72-foot dimension, we've got 72 feet by 132 feet. Okay. If 1 inch equals 6 feet, then what would 72 feet represent on that or in that model? So let's say 72 divided by 6 is going to give me 12 inches. Okay. And 132 feet. Okay, since 1 inch equals 6 feet, for every 6 feet I've got in here, I'll have 1 inch on my model. I'm going to divide that by 6, and I get, what do we get? 132 divided by 6. You're going to get 22 inches. Okay? So does that make sense? If 1 inch equals 6 feet, then 12 inches equals 72 feet. And 22 inches equals 132 feet. So what would be the dimensions of the model using a scale of 1 inch equals 6 feet? It would be 12 inches by 22 inches. Okay. All right, guys. Hope you found that helpful. That is our whole unit on proportions and similarity. And good luck on the homework. And don't forget to come back and check this out again. If you struggle with any of the problems, don't be afraid to play it again, pause it, check it out, and good luck.